Hello friends, welcome to the second part of our exploration of the Bang Olufsen BeoSystem 1 AV processor. In the first part I took apart the entire thing down to boards and cables and boxes. In this part we're going to take a closer look at the three power supply modules as well as this power input module. So stay tuned. So I've got selected pieces connected together. Taking you down the line, we start with this isolation transformer that I made in another episode. We've got our line voltage and watt meter we already used. This is the inside of the power conditioner module. One major power supply. Second major power supply. This is the top video board that has the composite outputs. This is another board. I'm just using those as a load for the power supply because some power supplies require a load in order to work properly. So the isolation transformer isn't maybe necessary, but it's an additional safety measure in case I accidentally poke some high voltages inside these power supplies. These capacitors are here and here are typical for this type of switching power supply, rated at several hundred volts, which is typically used on the internal sections of a switching power supply, even though the output voltage might be in the 3 or 5 or 10 range. So we're going to turn all this on and find out what happens. So now I'm turning it on. We've got 120 volts out of our isolation supply. We'll go to amps. We've got 0.13. I'm going to try to measure some of the voltages with the voltmeter next. Here's an interesting thing. I'm hearing the hum of the isolation transformer go in and out in association with the changing current here. So it's as if the power supply board is kind of cycling on and off. This is our power conditioner board. I'm going to turn on the voltage here. We've got 120 volts again on the input as expected. On the output I'm on AC volts and I'm reading 17.6 or 7, about 17.7 volts AC. So the 17 volts corresponds to now it's showing about 18 volts corresponds to this big power supply with this large heat sink. So here's the power supply that takes in the 18 volts. Now we're going to go over to this other one and see what the volts that goes into that is. So this power supply corresponds to the yellow leads over here. It says TV1 on this little board. So that's giving me 120 volts. So that's a direct connection, it looks like, from the line to this other power supply unit. Now the outputs of this unit appear to be some combination of this connector, and another connector over here. We got a stray ground that goes somewhere. I'd have to look back at my other footage to find out. So it's hard to know what the outputs are supposed to be. Now, I haven't established what the reference ground is on the output side of this. So we'll probably do that as a second step. We'll come back to that one. Now this one, based on the coloring, is going to be more obvious. We can reasonably assume that black is ground, red is some sort of primary voltage, and yellow and blue are some other kind of auxiliary voltages. So we'll do black here and red here. After a little adjustment of turning things on and moving them over, let's look at our voltages. Red is 5 volts. Yellow is 15 when turned on. I just heard the transformer hum. That's going to go off in a second. Transformer went off. That dribbles down to 0. So this seems to be the voltage that's cycling on and off through some sort of safety mechanism of the board. Now let's look at our blue, minus 15. I'm going to guess that'll cycle on and off also. Oh no, that one's constantly on. So the 15 and minus 15 are probably for analog type components. Here we're cycling off, on, that sort of thing. So this power supply seems to be working fine, although there's some element of turning it on and off. So if I'm going to reuse this on some other project, I would need to figure out how to keep it on. Well, this is kind of fun. During the disassembly process, I broke part of the tab of this connector off, and doing it just now, I broke the other part off. So that's something that hopefully they've improved in the last 20 years. So having disconnected that board, we'll see if this power supply stays on or cycles on and off as before. Or it might not come on at all, because a lot of times power supplies like this need a load to operate correctly. So we got 0 volts there, 0 volts there, and 0 volts there. So due to some sort of load or control situation, this power supply won't operate disconnected. Not too surprising. Here we've got minus 12.3, minus 12.3, minus 12.1, a little less, minus 11.9, minus 11.64. So, kind of assumed this one on the end is a ground, but that may be wrong. So all the minuses might be pluses here. So let's move over to this other connector. Nothing measurable over here. So that's probably another one that is normally off. So with no load connected to the power supplies, we've got essentially 0 amps coming through our 120 volt AC line. That makes sense for this type of switching power supply. Even though it's supplying some sort of nominal voltage, it's efficient enough that you probably wouldn't measure any current at the 120 volt input point. So what we learned about our power conditioner here is it's providing a pass-through 120 volts, which might have some conditioning on it of some kind. It's got what looks like a relay here, and this appears to be a step-down transformer stepping down from 120 volts to whatever we measured earlier, 17. So this type of transformer would provide both step down and isolation if they intended for that. I don't know what their isolation concept is here to here, except that just topologically speaking, it looks like we come straight in to the board here. These could act as isolation transformers as well as line filters. This appears to be bridge rectifiers, a relay of some kind, maybe, or a capacitor, I'm not sure offhand. This is another transformer, this very strange transformer. Lots of control ICs, high voltage filter cap. Got a probably a MOSFET switching transistor here, or there may be one inside, I'm not sure. Probably got an output transformer, more MOSFET switching, or this may be a dual transformer of some kind. And this appears to be the output section of it, which has some smaller size filter caps and these big cables that are delivering power to this board. Rearrange things a little bit here. So it looks to me like, from a salvage point of view, this power conditioner board together with this power supply board could potentially be useful for some sort of reuse purpose as is. We'd have to figure out how it works and what it takes to make it stay on. Here's something I keep wondering about. What is this big black heatsink looking thing? It's got some markings on it, 17.5 VA, 15V, 115V on the end here. So it looks like some sort of transformer, maybe with some other components included. So we'll look that up and then show you what we come up with. So after a little quick internet research, I found out this is a Telema toroidal transformer. Has two 15-volt outputs center tapped, so that could be 30 volts total. Has a rating of 35 volt amps, so for practical purposes probably 35 watts. And the model number is 70073K. This one here is have to do a lot more work to figure out what it does and how to use it. It has maybe more different outputs. Could also be potentially salvaged for parts. In all honesty, these both may go on the shelf for some sort of hobby project that has yet to be invented that I might come up with. But I think we've got potentially I'm more interested in these two as a useful pair. We can put the plastic enclosure back on top of this one and do a little bit more engineering to figure out what's going on here. This one I'm not going to reverse engineer any further at this point, maybe in some future episode. But since this just takes in this 120 volts directly with no isolation, it doesn't have any real need for this board. I want to confirm that a little bit, but to make sure that this connector that normally connects to it is a direct path to the wall prong, but it looks like that's probably the case. And that means that the power conditioner plus this supply have a useful purpose, and then this supply could possibly be used on its own for some other purpose. That ends our tour of the power supplies inside the Bang Olufsen BeoSystem 1 AV processor. Hope you enjoyed it. Thanks for watching. Bye-bye.